Hello, viewers. In today's session, we are going to discuss an important problem from integration using the method of partial fractions. Right. So here we are going to evaluate this definite integral where we have the limits 0 to 1 and the integrand is 2x plus 5 divided by x plus 1 times x square plus 3. Right. So here the integrand is a rational function, right? So here the rational function r of x may be given by 2x plus 5 divided by x plus 1, and here we have x square plus 3, right? So the integrand is a rational function, and this rational function is the quotient of two polynomials, right? That is, here we have a p of x, which is 2x plus 5, and in the denominator we have the product of this linear factor with this quadratic factor, and the denominator may be denoted by q of x, right? So here the integrand is a rational function r of x, which is the quotient of two polynomial functions p of x and q of x. So here, to get the value of this definite integral, we'll make use of the method of partial fractions. So here this rational function can be resolved into partial fractions, and here we see that the degree of the numerator is 1 and the degree of the denominator is 3, because when we multiply this linear factor x plus 1 with this quadratic factor x square plus 3, then we get a polynomial of degree 3, right? So here the degree of the numerator is less than the degree of the denominator. And moreover, here we can see that the denominator is a combination of linear factor of this form, that is say ax plus b, and the quadratic factor, that is x square plus 3, and we can easily here see that this quadratic factor x square plus 3, it cannot be resolved into real linear factors, that is x square plus 3 is not factorizable into real linear factors, or we can say that x square plus 3 cannot be resolved into linear factors in the set of real numbers, right? So whenever we have a rational function of this type, then the partial fractions can be written as a over x plus 1. So here we have the linear factor x plus 1, so we have the constant a, and then we have x plus 1, and here we have x square plus 3. Now this quadratic factor is it cannot be resolved into linear factors in the set of real numbers. So here the numerator is of this form, bx plus c, and the denominator is x square plus 3, right? So whenever we have a rational function of this type, that is say here we have say lx plus m divided by, say here we have ax plus b times, here we have say px square plus qx plus r, right? So whenever we have an integrand of this form where the numerator is a linear factor and the denominator is a product of linear factor and a quadratic factor, and the quadratic factor cannot be resolved into real linear factors, then the partial fractions can be written like this: a over ax plus b, and then we have bx plus c divided by px square plus qx plus r, right? So here we have for ax plus b we have x plus 1. For px square plus qx plus r we have x square plus 3, right? So here we do not have this term qx, and lx plus m is given by 2x plus 5, right? So the partial fraction of this rational function are given by a over x plus 1 plus bx plus c over x square plus 3. And now our aim is to get the values of a, b, and c, right? So here what we will do, will take the here we have the LCM, that is x plus 1, then we have x square plus 3, and then we can write a times x square plus 3, and then we have bx plus c, and here we have x plus 1, right? So this expression can be written like this. And now we have here 2x plus 5 divided by x plus 1, and here we have x square plus 3, right? So now we have here 2x plus 5 is equal to this expression, that is a times x square plus 3 plus bx plus c times x plus 1. So now from this expression we can find out the values of a, b, and c using the concept of comparing the coefficients on both sides, right? So we can now write here 2x plus 5, and here we have ax square plus 3a. Then we have here we can multiply these two binomials, so we have bx square plus bx, and then we have cx plus c, right? So now this expression can be written as 0x square plus 2x plus 5, and here we can collect these two terms, a plus b, then we have x square, then we can collect these two terms, we have b plus c times x, and then we can collect these two terms, that is 3a plus c, right? So now if we compare both the sides, that is comparing the coefficient of x square here, and then comparing the coefficient of x, and then the constant term, we can now have a plus b is equal to 0. So here we have a plus b is equal to 0. Then we have b plus c is equal to 2, and then here the constant term 3a plus c is equal to 5. So now we have three equations and three variables, right? So we can now solve these three equations to get the values of a, b, and c. So now from equation 1 we can write a is equal to minus b, right? And here we can now substitute b is equal to minus a in equation 2. So here taking b is equal to minus a, we have equation 2 as minus a plus c is equal to 2, and here we have the equation 3, that is 3a plus c is equal to 5. So now we have these two equations. Now if we subtract both these equations, then here we have the negative sign, and negative sign, right? So subtracting 3a plus c is equal to 5 from this equation, minus a plus c is equal to 2. Here we have minus a minus 3a, that is minus 4a. here c and minus c get cancelled. 2 minus 5 is minus 3. So we have a is equal to minus 3 over minus 4. That is simply 3 over 4, right? So we have the value of a as 3 over 4. So now if we take a is equal to 3 over 4 in this equation, then the value of b is minus 3 over 4, right? And to get the value of c, we can make use of this equation 2. So we have the value of b as minus 3 over 4. Then we have plus c is equal to 2. So c is 2 plus 3 over 4, taking minus 3 by 4 to this side. And here we have 4 times 2, 8 plus 3 over 4, that is 11 over 4. So the value of c is 11 over 4, right? So now substituting these values in this equation here, we have 2x plus 5 over x plus 1 x square plus 3 equal to 3 over 4 divided by x plus 1. And here we have b minus 3 over 4 x, and then we have 11 over 4, and here we have x square plus 3, right? So now we can write this expression as 3 over 4 times x plus 1. And then here we can now split this expression like this, that is minus 3 over 4. Then we have x over x square plus 3, and then we have 11 over 4, and here we have x square plus 3, right? So we have now 2x plus 5 is 2x plus 5 over x plus 1 times x square plus 3 equal to this expression, right? So now we have to first to find out the indefinite integral of this function. So we can now write here the integral, then here we have the integral, and then here we have the integral, and then here we have the integral, right? So the indefinite integral of 2x plus 5 over x plus 1 times x square plus 3 is given by 3 over 4, taking 3 over 4 outside the integral. Then we have here dx, then we have dx over x plus 1, then we have minus 3 over 4, here we have x dx over x square plus 3, and here we have 11 over 4, and here we have dx over x square plus 3. So now we have to find out the these three integrals, right? Now see, here we have x square plus 3, and here we have x, and the derivative of x square plus 3 is simply 2x. So what we will do here, we'll write 2, and here we'll write 2. That is multiplying the numerator and denominator by 2, so that the derivative of x square plus 3, it appears in the numerator, right? And here we have x square plus 3. So x square plus 3 can be written as x square plus root 3 square, right? So now here we have 3 over 4, and the integral of 1 over x plus 1 is simply a logarithm of x plus 1, right? Because we know that integral dx over say x plus a is equal to integral that is a logarithm of x plus a. So the integral of 1 over x plus a is logarithm of natural log of x plus a. And here we have minus 3 over 8. 4 times 2 is 8, and the integral 2x over x square plus 3 is simply a natural log of x square plus 3, right? Because we know that if we have the integral, say f of x, here we have f of x in the denominator and its derivative in the numerator, then the integral of the indefinite integral of f prime of x divided by f of x is simply natural log of f of x, right? So here we have 2x over x square plus 3. So if we take f of x as x square plus 3, then f prime of x is simply 2x. So this integral is of this form, where the integrand is f prime of x divided by f of x. So the indefinite integral of f prime of x divided by f of x is natural log of f of x. So here we have minus 3 over 8 natural log of x square plus 3. So the purpose of multiplying the numerator and denominator by 2 is to get this form, right? Now here we have plus 11 over 4. Now this is a standard integral, that is integral dx over x square plus say a square. And here we know the direct formula, that is 1 over a tan inverse x over a. And here we have 1 over x square plus root 3 square, that is 1 over x square plus a square. So the purpose of writing 3 as a root 3 square is to convert this integrand 1 over x square plus root 3 square in this form, 1 over x square plus a square, where a is equal to square root of 3. So applying this result to this integral, we have 1 over a, that is root 3, and then we have tan inverse, and here we have x over a, that is x over root 3, right? So this is the required indefinite integral of 2x plus 5 over x plus 1 times x square plus 3. And here it is important to note that when we write natural log of x plus 1, we can also write it as natural log of mod of x plus 1. And here we can also write natural log of mod of x square plus 3. But here we'll prefer this notation, that is simply the brackets. So we have natural log of x plus 1, natural log of x square plus 3. We can also use this notation also, right? And here if we wish to find out the indefinite integral, then here we must add the constant of integration, right? So the indefinite integral of this rational expression or rational function is given by 3 over 4 natural log of x plus 1 minus 3 over 8 natural log of x square plus 3 plus 11 over 4 root 3 tan inverse x over root 3 plus c. But here we have to find out the definite integral. So now we can write here 0 to 1, and we have 2x plus 5 and x plus 1 and x square plus 3 dx. And when we have to find out the indefinite definite integral, then we have to discard this constant of integration, because we have to simply substitute the limits, and we have to take the difference. So first we'll take x is equal to 1 in this expression, and then we'll take x is equal to 0 in this expression, and then we'll take the difference to get the required value of this definite integral. So now if we call this integral as I, then here we can write the value of I as first we take x is equal to 1. So we have here 3 over 4. 1 plus 1 is 2. So we have natural log of 2. Then we have minus 3 over 8. Natural log of here we have x is equal to 1. 1 square plus 3 is 4, and 4 can be written as 2 square, and then we have 11 over 4 root 3, and here we have a tan inverse x over root 3, that is 1 over root 3. Then we have the negative sign, that is we have to take the difference, and then we have x is equal to 0. So we have 3 over 4, and 0 plus 1 is 1, that is a natural log of 1, and natural log of 1 is 0. So here we have 0 minus 3 over 8. Then we have natural log of, here we have 0, so 0 plus 3 is simply 3, and here we have plus 11 over 4 root 3, and when we take x is equal to 0, then this term is 0. X over root 3 is 0, and tan inverse 0 is 0. So here we have 0. So now we can write 3 over 4 natural log of 2, and using the properties of logarithms, that is log of say a raised to b is b log a. So here when we take 2 in front of the log, then we have minus 3 over 8 times 2 times natural log of 2. So this is 2 times 4. So we have here a minus 3 over 4 natural log of 2, and then we have 11 over 4 root 3, and tan inverse 1 over root 3 is equal to pi over that is 6, right? Because we know that tan pi over 6, that is tan 30 degrees, is 1 over root 3. So here we have pi over 6, and then we have the negative sign. This term is 0, this term is 0, and here we have simply minus 3 over 8 and natural log of 3. So now these two terms get cancelled, and here we are left with 11 over 4 root 3 times pi over 6, and here we have minus times minus is positive, and here we have 3 over 8 natural log of 3, right? So the value of this integral is given by this expression, and we can also write this expression as 11 pi over 6 times 4 is 24 root 3, and then we have 3 over 8 times natural log of 3. So this is the required value of this definite integral using the method of partial fractions.